Hello YouTube. In today's video we'll be reviewing some synthetic silicon carbide 4H, and all of these are precision faceted, machine cut, 1.5 millimeters in diameter, round brilliance, and these are not coated Moissanite. These are plain Jane, run-of-the-mill, regular Moissanite. The tweezers that I'm using are stainless steel, Swiss made, designed for small melee stones. The digital calipers that I'm using is accurate to within 1/100th of 1 millimeter. The stainless steel sieve is designed for parcels of loose melee and sorting it. The white background is a paper notepad. It's used to absorb shock in case if I accidentally hit the tweezers to the sieve or I lose grip with the melee. It's used to absorb the shock, and it will be demonstrated on what else I use it for in the next few minutes, where I take the stones and use it as a read-through or a refractive index indicator. So as you're seeing, most of these little Moissanite melee are pretty precision faceted down to the millimeter or the 100th of a millimeter, and that's because these are machine cut, and they're cut with lasers and faceted by robotic laps. These stones are mass-produced, and surprisingly, they're very, very inexpensive. Okay, no more than a few cents for stone on these size of melee. This is one major contributing factor of why these Moissanite are so popular currently, because the price is very affordable, they're mass-produced, they come precision faceted, and they're perfect for a jewelry manufacturer specializing in fashion jewelry to cast set into place thousands of stones into a piece of jewelry. And optically speaking, Moissanite has a high refractive index with a high hardness and very strong brilliance, and this is another contributing factor of why it's used solely as a diamond simulant. Although technically it's a doubly refractive gem, it is considered in the jewelry trade as a diamond simulant. That is the facts. And the biggest contributing factor of its popularity is it's a very good thermal conductor, and so it passes these thermal conductivity probes, and that's what increased the popularity of this material. Strontium titanate is the most highest refractive synthetic simulant with the greatest amount of fire, but the downside of strontium titanate is it's very soft, and that is reason why that material isn't popular as Moissanite in the fashion jewelry world. Alright, so here's a digital multimeter, and this is for the Moissanite Moissketeer task force that maybe give me problems that the 9-volt battery isn't charged. So here I am just demonstrating that that number right there is 25. This is a 9-volt battery, 9V25. So I'm putting the positive and the negative, and we're seeing that it has 26. So this is an overcharged, so it has perfect amount of charge to do the next demonstration with the dual thermal conductivity, electrical conductivity probe. So I was just given a probe tip check, and it's a copper probe tip, and copper, it oxidizes. So here is a cardboard and I'm simply just rubbing the oxidation off of the probe tip very vigorously, but not too hard, not to bend the probe tip. But what I'm going to do is just give it a check with magnification, make sure it's nice and shiny, and we're going to be doing some electrical conductivity and thermal conductivity test on these little Melly Moisketeers. So take a look at it under 10x, looks good, and we're ready to test. So now the white background paper notepad is going to be used to do a simple pavilion flash test, and all I do is I'm going to indicate that, okay, this has higher RI, and then I have a little micro dot on the right side, the lower right side, and I'm simply going to do that dot test just to demonstrate to the viewers that this is a high refractive index material. So I'm nice and square with the table, with the probe tip making contact with the table, and it gives us a semiconductive reading, aka it's moissanite. And these stones are perfect size for this little slot, this aluminium loose stone tester, and I have no problem with putting the stone into the test slot. Right now I'm putting it pavilion side up, and I'm going to test the culet just to see if the same conductivity is on the pavilion side. And we get the same reading. It is a semiconductor on the pavilion side. And I'm going to test another stone using the tweezers. You see that it goes in there nice, and what I do is I just tap it just to make sure it's secure and it doesn't flick out. So notice how I kind of flick it and just make sure that it's a high refractive index, no read through, and I place it on the dot, didn't get any read through on that. And the reason why I'm testing with the probe tester on the culet is because a lot of people requested for me to do this just to demonstrate the semiconductive properties of moissanite, as it's not straightforward. And some may test as metal, and it's not anything wrong with the tester itself. It's just that indicates that that material is higher electrically conductive or a greater semiconductor as the other moissanite. That's all that it is. And it can be grown from the same bull, and the conductivity is different just because the impurities or metal that's crystallized within the moissanite itself. So we're coming up on a moissanite that is a greater semiconductor than the rest, as you can see that it indicated as it's metal, and I'm squarely touching that stone without touching the probe to the metal. So let's see how it reacts when we place the stone table down. You guys see that little flash, you know it's a high refractive gem, has no read-through as indicated. So I'm going to now test the culet and just see if the same semiconductor properties are on the culet as well as the table. This stone kind of popped out, but watch that I pick it up with that arc and I place it back in the testing slot. Pretty cool. I test this stone a few times just to demonstrate that the probe tip is making direct contact with the table facet, and it gives a metal reading because this has a higher semiconductive property than the rest of the moissanite. We can see here when I'm testing the culet, it doesn't read as metal because it has a lower semiconductive property below the pavilion. I test this stone a few times just to demonstrate that I'm making direct contact with the probe tip to the table facet, and it's still giving a metal reading. All this tells me is it's a higher electrical conductor, semiconductor than the rest of the moissanite. That's it. Pretty simple. This moissanite also tested as metal on its pavilion side, meaning that this is a very high semiconductor. Okay, we're back for round 2, and we're going to be testing more Moissanite Melee Moissketeers. Okay, on this stone, it tests as metal on its pavilion side, so it has a higher electrical conductivity, or it's a higher semiconductor than the table side. I had a few subscribers reach out to me to test carbon-coated or DLC-coated CZ, in which I will at a later video. Another thing that the question I got asked was, does the coated CZ test as diamond or CZ? And that is absolutely not. Cubic zirconium dioxide is a thermal insulator, and it has very, very, very poor thermal conductivity properties. It's a thermal insulator. So I just thought I would add that in this video. You guys are starting to understand that even though it's a small stone, the read-through, the refractive index test, by just doing the pavilion flash and doing the dot test, it's a highly reliable segregator. And it's very easy to determine a high refractive gem through a low refractive gem on a colorless or near colorless gem. And it could be diamonds, moissanite, or synthetic diamonds. Okay, so we're about to see that a stone with a very thin girdle tends to just jump off without tweezers. And that's just how it is. It can't get a grip, and it's pretty scary. But thankfully, I have a notepad, and it helped kind of reduce some of that ricochet. Or else I would have had to mine it from the carpet, and that's not too fun. Even though these are big boy pointers, and I could probably, see it in the carpet, it's not fun to do that on a very small stone. So this stone also tested as metal on its pavilion side. That simply just means it has a greater semiconductive property. So all of these stones that I've tested, these are not the stones that the manufacturers who diamond coat the moissanite, they will not use these because they could still detect semiconductive properties with a thermal probe. What they're doing is they're using very low conductive material, and then they're further coating the stone to reduce its semiconductive properties. And they are essentially electrical or semiconductive insulators. So they have no conductive properties. And that's how, they pass all these probe testers.